It finally happened. Elon Musk just revealed 3 brand new electric vehicle battery technologies that could completely upend the entire EV industry. These batteries aren't just incremental upgrades, they're massive breakthroughs. We're talking longer range, faster charging, lower cost, and enough energy density to make gas engines feel ancient. In this video, we're breaking down each of the 3 new battery types Tesla is working on in 2026, what makes them so groundbreaking, and why legacy automakers are officially in panic mode. Make sure you stay to the end, because one of these batteries could be powering the next generation of Teslas, and possibly your house. Expanded solid-state battery analysis. Solid-state batteries are the holy grail of EV technology, and Tesla's take on it could be a game changer. Traditional lithium-ion batteries use liquid electrolytes, which can be volatile and prone to overheating. Tesla's solid-state design replaces the liquid with a solid ceramic or polymer-based electrolyte, making the battery significantly safer and more energy-dense. What sets Tesla apart from competitors like QuantumScape and Toyota is its hybrid approach. Tesla is combining thin ceramic layers with flexible polymers to maintain conductivity while avoiding cracking under mechanical stress. In internal trials, this new configuration demonstrated a 50% increase in energy density and allowed full charges in under 15 minutes without degradation. According to engineers, this design can last over 1,000 charge cycles before reaching 80% capacity, a massive improvement over current lithium-ion standards. While competitors are still trying to get their prototypes past the lab stage, Tesla is reportedly running real-world endurance tests in extreme temperature conditions, something very few others have achieved. The goal is to deploy these batteries first in Cybertruck variants, and eventually, the long-rumored Tesla Roadster 2. This breakthrough could push electric vehicles past the 600-mile range barrier and make EV ownership even more practical than owning a gas-powered car. Expanded 4680 plus cell tech and manufacturing. Tesla's 4680 cell has already received plenty of attention, but the upgraded 4680 plus version adds several revolutionary elements. The key change? A completely dry coating process for both the anode and cathode. This eliminates the need for toxic solvents and high-temperature drying ovens, cutting down manufacturing costs and CO2 emissions. The dry coating technique uses high-pressure rollers to bond electrode materials, creating thinner, more uniform layers. The result? Faster ion transfer and more compact energy storage. Tesla claims this process reduces battery costs by over 30% per kilowatt-hour, while increasing volumetric energy density by 20%. What's more, the 4680 plus cell architecture integrates more seamlessly with Tesla's structural battery pack design. These cells act as a load-bearing component of the vehicle, eliminating redundant materials and making the vehicle chassis lighter and stiffer. The Model Y and Cybertruck will likely be among the first vehicles to benefit from this tech, potentially enabling them to achieve greater range and performance without any size increase. Analysts predict that the 4680 Plus could be the default battery type in all Tesla models by 2027. Combined with gigafactory expansion in Texas, Berlin, and Mexico, this positions Tesla to scale faster than any other EV manufacturer in the world. Expanded sodium-ion battery use cases. Sodium-ion batteries aren't just a cheaper alternative to lithium, they're an entirely different way of thinking about energy storage. Tesla's interest in sodium-ion is primarily driven by 2 things: cost efficiency and resource abundance. Sodium is far more plentiful and evenly distributed across the globe than lithium, making it less vulnerable to supply chain disruptions and price volatility. Tesla's pilot sodium-ion project is focused on entry-level EVs and stationary energy storage products like the Powerwall and Megapack. These batteries deliver slightly lower energy density compared to lithium-ion, but they perform exceptionally well in cold climates and can handle more charge-discharge cycles without degradation. This makes them ideal for customers in places like Canada, Norway, and northern China, where temperature swings kill traditional battery performance. The real breakthrough? Tesla's proprietary electrolyte additive increases sodium-ion conductivity by 40%, closing the performance gap with lithium cells. If scaled successfully, sodium-ion batteries could drop EV prices by up to 25% and accelerate mass adoption in developing markets. Even more interestingly, Tesla is reportedly exploring dual chemistry packs, blending lithium and sodium-ion cells in a single vehicle to balance performance and cost. If that pans out, it could revolutionize how battery packs are designed industry-wide. Global industry impact. With 3 parallel battery technologies in development, Tesla is doing something no other automaker has ever attempted: creating a flexible battery ecosystem. By tailoring chemistries to specific use cases, high performance, low cost, or stationary storage, Tesla can dominate every corner of the EV market. This multi-pronged approach puts enormous pressure on competitors. GM, Ford, and Volkswagen have all bet heavily on lithium-ion and can't pivot easily. Meanwhile, startups like Rivian and Lucid are still stuck sourcing battery cells from third parties, making it hard to compete on cost or speed. Investors are taking notice. Tesla's recent stock surge wasn't just hype, it was driven by leaked internal documents showing battery production costs dropping below $80 per kilowatt hour. That figure shatters the industry's long-held $100 per kilowatt hour target and marks the threshold for EVs to match gas cars in sticker price. As a result, analysts are projecting that Tesla's total addressable market could triple by 2030. From affordable sedans to semi-trucks and grid-scale batteries, they'll have a custom battery for every segment. Tesla's materials sourcing strategy. To support its aggressive battery expansion, Tesla has made bold moves upstream in the supply chain. The company has secured multi-year agreements with lithium, nickel, and graphite suppliers across North America, South America, and Australia. Tesla is also investing directly into mining operations, with Elon Musk famously stating that Tesla might become a mining company if needed. This strategy isn't just about controlling costs, it's about vertical integration. Tesla wants to ensure the materials used in their batteries meet their environmental and ethical standards, particularly when it comes to cobalt and lithium, which have been controversial due to mining practices in some regions. Tesla is also exploring alternative extraction techniques like direct lithium extraction, DLE, which promises lower environmental impact and faster processing compared to traditional methods. If successful, these methods could unlock new lithium resources in places like Nevada and Alberta, giving Tesla a domestic supply advantage over competitors dependent on Chinese imports. By locking in these supply chains early and building refining facilities close to its gigafactories, Tesla ensures resilience and pricing stability, giving it another competitive edge in an increasingly resource-constrained world. Rollout timelines for each battery tech. Tesla has laid out an aggressive yet phased approach for deploying its 3 major battery technologies. The 4680 Plus cells are already entering low-volume production and will see wider use in 2026, with vehicles like the Model Y, and semi-state batteries, are still undergoing endurance testing, with pilot programs expected by late 2026 and volume deployment potentially in 2027, likely starting with limited edition or premium vehicles. The Spirit ion batteries are on the fastest track for mass production due to their affordability and simplicity. Tesla's Shanghai and India-based gigafactories are expected to begin small-scale production by early 2026, focusing on energy storage and budget EV models. Tesla's ability to ramp each chemistry in parallel is what truly sets it apart. While competitors focus on one chemistry at a time, Tesla's modular factory design and software-driven processes allow them to switch between battery types on the fly, maximizing uptime and output. This multi-tier strategy means Tesla can adapt to changing market conditions, resource availability, and customer needs, all while continuing to push battery technology forward. Global policy and EV market influence. Tesla's battery innovations don't just disrupt the automotive industry, they have massive geopolitical and environmental implications. Governments worldwide are racing to implement stricter emissions targets and EV incentives. Tesla's new battery lineup makes it easier for nations to meet these goals by making EVs more accessible, reliable, and sustainable. In the U.S., Tesla is working closely with regulators to qualify for new federal tax credits tied to domestic manufacturing and mineral sourcing. In Europe, Tesla's Berlin Gigafactory plays a pivotal role in helping the EU reduce reliance on Asian battery imports. And in Asia, Tesla's strategy to produce sodium-ion cells locally in China and India aligns with those countries' push for clean energy independence. These moves position Tesla not only as a market leader, but as a key strategic player in global climate policy. With every battery Tesla builds, they're also shaping the infrastructure, legislation, and economic incentives of the EV future. Conclusion. In 2026, Tesla isn't just releasing new batteries, they're redefining what's possible in energy and transportation. With solid-state, 4680+, and sodium-ion technologies all moving toward commercial deployment, Tesla is covering the full spectrum, from premium performance to affordable mass-market mobility. If successful, these technologies won't just benefit Tesla, they'll force the entire industry to evolve, accelerate global decarbonization, and make EVs the default for the next generation. And knowing Tesla's track record, they just might pull it off. So, what do you think? Will these battery breakthroughs be the tipping point for mass EV adoption? Let us know in the comments, and don't forget to subscribe for the latest Tesla updates. Thanks for watching.